In this class, we will learn how to use native JavaScript full-screen functionality, how to add touch support to our games, and how to measure length and direction of swipes so that we can attach specific events to them. Full series linked in the video description. Let's make a mobile game with HTML, CSS, and JavaScript. Let's go! This is the game we built in the previous lesson. I will be using Google Chrome browser as usual, and if I right-click to inspect the page, we have this small mobile device icon here. This tool is great for designing responsive websites. Keep in mind, this is just an estimate. There might be some differences when you run the same code on the actual device. This simulator is not 100% accurate. As you can see, Canvas doesn't even fit mobile screen on landscape. Currently, this project is not mobile friendly at all. It's actually very easy to fix this. I can click this icon to toggle between landscape and portrait view. I can choose different devices from this drop-down. So the first thing I want to do is to make sure we can see the entire canvas at all times on mobile. I will do it with CSS. I give canvas max width property of 100%. We are missing left border here. Let's reset all default margins and paddings and set box size into border box to make sure element's border is included in its total width. Modern CSS makes life so much easier. So now in portrait mode, you can set canvas to any width and it will always scale up or down to make sure we can see all of it. I switch to landscape and we have the same problem. How do we solve this? This is actually also very easy, barely an inconvenience. I give canvas max height 100%. Now canvas will scale until it hits edges of screen vertically or horizontally, depending on aspect ratio, whichever boundary it hits first. Look what happens when I make canvas wider. It still works. I can switch devices, toggle between landscape and portrait. We can see all of canvas at all times. Perfect. There is also a way to make canvas fit the entire screen with no black edges, but because of the scrolling background we're using here, I would have to calculate aspect ratio. I want to keep this class beginner friendly with no algorithms, so I will get back to that in more advanced tutorial. Now you know a quick and easy way to make canvas fit on mobile screen without stretching and distortion. The only way to restart game right now is to refresh browser window. Let's write an actual restart game function so that we can connect it to buttons or key presses or touch events. We have to think what needs to happen when game restarts. Well, first we need to restart the player to its initial position. I will actually do it as a method on player class. I will call it restart, and inside we set X and Y to the original values. Let's move player 100 pixels to the right, here and here. That's better. After restart, I want player in a running animation, so max frame will be 8 and frame Y is 0. Down on line 200, inside our custom restart game function, I take instance of player class from line 205 and I call restart method we just wrote. I don't really have to restart background, or maybe I will just restart its exposition back to 0 so that we get some more visual feedback that we are actually starting a new game. Again, I take an instance of background class from line 210 and I call restart method we just wrote. The last thing I need to do when game restarts is to take enemies array, score and game over and set them back to their initial values. Notice I'm removing let keywords because I'm not declaring new variables, I'm just assigning new values to existing variables. Where do we call this restart game function from? Here inside event listener, inside key down event, we listen for arrows and we push them into this .keys array. I will create an else statement, and if key that was pressed is enter, and at the same time game over from line 8 is true, we call the new restart game function we just wrote. It's still not working, and it's because when game over is true, I stop calling request animation frame here. Since we are setting game over back to its initial false value, I can call animate again to start new animation loop, like this. So we are playing, game is running, I get game over, I press enter and reset function resets our game. Awesome, we are doing great so far. I should tell the user to press enter, otherwise how would they know? You can see after game reset, score is off screen. It's because it's taking this text align center we used for game over message. I need to set text align to left here. And the message will be something like game over, press enter to restart. This works. Okay, touch events, this will be fun. First, I remove this console log from line 175. Up here inside input handler class, we will create a new event listener for touchstart event. It will run whenever user touches browser window. When that happens, I console log something. I will actually also need touchmove and touchend events. I'm gonna console log start in touchstart, move in touchmove, and end in touchend. The way these work, touchstart fires once as we start interacting with screen. Then touchmove fires over and over as long as we are moving finger over the screen, and touchend just fires once when user releases the touch. This is important to remember as we have to consider these when we are structuring our code. Code in touchstart and touchend will run once, and the code in touchmove will run over and over as long as the event is firing. This is actually very useful, and we can use touchstart to set something up, touchmove to make a calculation such as direction and time of the event, and in touchend we do some cleanup and discard or reset values we don't need anymore. There is no swipe up and swipe down event, so let me show you how you can easily use these three touch events combined to determine direction of swipe. Let's have a look at auto-generated touchstart event object by console login E. When I touch screen, this event fires and I can inspect it. There are many useful values here. For example, it keeps track whether Alt and Control keys were pressed at the time of the event. We have timestamp of the touch here, very useful, and the main thing we care about is X and Y coordinates of the touch. X and Y coordinates of touch event are stored inside this read-only changed touches property. It's a list that stores auto-generated touch objects that contributed to this touch event. With touchstart event, we get just one object, so we have to open index 0, and here we can see page X and page Y properties. Perfect, we know where on screen this touch event started. If I console log touchmove and I swipe across my screen, you can see that event fires many times. Let's go to one of the ones at the start. If I check inside change touches list at index 0, I can see page Y is 71. As I was swiping, the event was firing, so let's go to the last time it fired, and here I see page Y is 104. I know this particular swipe went vertically from coordinate 71 to coordinate 104. We have all these values we need to determine whether user swiped up or down. I put this console log into touchstart event and I remove all other console logs. To access vertical coordinate of touch event, I say e.changedTouches, index 0 because this is a list, and I want this page Y property. Okay, let's put that inside touchmove and touchend. I create a new property on input handler class. I call it, for example, touchY. It will store the initial starting vertical coordinate. Maybe I also want the game to only react to longer swipes, to make sure user actually swipes and the game doesn't accidentally react to simple short taps. I will call this property touchThreshold, and I set it, for example, to 30. I wanted the starting touch point and the ending touch point to be at least 30 pixels apart to trigger the event. I could also make the player jump higher here based on how long the swipe is. This technique is easy and very powerful if you are designing mobile games. I hope you are realizing the potential here. In touchstart event, I just want to set starting coordinate, so this.touchY from line 13 is equal to page Y value from this event. Let's delete all these. Inside touchmove, I will compare current coordinate and starting coordinate to determine direction, so let's have a temporary helper variable called, for example, swipe distance, and set it to page Y value of this tick of touchmove event minus the initial starting vertical coordinate, so minus this.touchY from line 13. Keep in mind that touchmove fires over and over again as long as user is swiping. I need more space here. If swipe distance is less than minus this.touchThreshold from line 14, so minus 30, we are swiping up, so this.keys push swipe up. This might be a little bit difficult to visualize for some of us, so here's some animation if it helps. At the same time, I want to check if swipe up is not yet in the keys array. So this is the distance between current vertical coordinate and starting Y coordinate. If this swipe distance is less than minus 30 and swipe up is not yet in keys array, push swipe up into keys array. Else, if swipe distance is more than this.touchThreshold, so plus 30, push swipe down into this.keys array. Also here I need to check that swipe down is not yet in the array before I push it in there. I don't want duplicates of the same value. In touchend, I just console log this.keys. I can see we are getting many duplicates in the array, so something must be wrong here. I zoom out a bit so I can see the whole thing on a single line. These brackets need to be here. Brackets are important, it's easy to make a mistake, and even a small thing can break the entire project. That's programmer's life. Attention to detail and debugging. Perfect, now it gets added only once per value. As I said, I will use touchend event for cleanup. I will use splice method to find swipe up in keys array and remove it. And I do the same thing for swipe down. So in touchstart, I save initial vertical coordinate of touch event. In touchmove, I compare starting vertical coordinate to the current vertical coordinate to determine whether user is swiping up or down. And in touchend, I clean up and remove all touch events from our custom keys array. Let's remove this console log. I want to restart game when we swipe down. I might as well put it in here, why not? So if we swipe down, call our custom restart game function we wrote earlier, but only do it if game over is true, like this. So I get game over, I'm swiping up, nothing happens. I swipe down and game restarts, great. I can increase touch threshold if I want some functionality to work only with very long swipes. I set it to 200, I swipe down but only short, nothing happens. Longer swipe, still nothing. I have to swipe almost the entire screen from top to bottom to restart game now. So let's put the threshold back to 30. I want player to jump when we swipe up, so here inside update method on player class I put this part in brackets because I want it to evaluate first. If keys array contains arrow up, or if it contains swipe up, and at the same time if player is on ground, make player jump. Be careful about brackets, it's easy to create a bug here if you forget one. Let's see, reload game, I run, swipe up and player jumps. I swipe again and again. This works! Touch events work really well with simple games like this. In the next episode I will create a game with more complex moves and special abilities. Game like that is a bit more complicated when it comes to touch events. Also, in most cases, to make a mobile game like this work, you should resize your art assets. My player sprite sheet has frames 200 x 200 pixels, that's massive for a mobile game, and if I had many animated objects on screen at the same time, it would start lagging very fast. For a bigger game, I would have to create 2 or more sets of art assets for different screen sizes. Let's change game over message so that user knows we can now swipe down to restart. JavaScript also offers built-in native full-screen API that's easy to use. It's now well supported in all modern browsers. As far as I know, only Internet Explorer and mobile version of Safari don't fully support it. We are web developers here, so I'm sure all of you use updated version of a modern, secure browser on your machine. Fullscreen API gives us methods that allow us to present a specific element and its descendants in a full-screen mode. It will hide all browser user interface elements, sidebars and other applications as long as full screen is active. Let's create a button to toggle full screen. I give it ID full screen button, for example, and it will say toggle full screen. In CSS I give it position absolute, font size 20 pixels, padding 10 pixels, top 10 pixels, and transform translate x -50% to center it horizontally. I bring it to my JavaScript project using getElementById. I create a new function I call, for example, toggle full screen. Let's console log document.fullScreenElement like this and call toggle full screen function we just wrote. Full screen element is a built-in read-only property on document object that returns the element that is currently being presented in full screen mode. If it's null, it means the full screen is not active. We can use this property to check if we are currently in full screen mode. I say if full screen mode is not active, take canvas variable from line 2 and call built-in request full screen method. This method is asynchronous. It returns a promise, which means I can chain then and catch methods to run some follow-up code when the promise is fulfilled or rejected. I will just use catch today to display potential error. Notice that the request full screen is called on the element I want to make full screen, but full screen element property sits on the document object. Today I won't put any follow-up code in then method, so I can delete it. In catch, I will take the auto-generated error object. If error happens, we will create alert, and it will say some error message. To concatenate message, I can use backticks instead of quotes. This is so-called template literal syntax. It's just a simple way to combine strings of text and expressions that need to be evaluated into a single final line of text. I say, for example, error can't enable full screen mode. And to insert variable or expression inside template string, we use $sign and brackets like this. Here I just put this auto-generated error object and its message property so we can read what went wrong. So if full screen is currently not active, present canvas in full screen mode. Else, meaning full screen is active, call built-in exit full screen method to switch back to windowed mode. Notice that exit full screen is again called from document object. If I save my project and refresh browser window, I get an error. You can see catch method worked and created alert pop-up window with our message. In console, I can see more information. It says full screen can only be initiated by user gesture. Here I declared my toggle full screen function, and here I'm calling it on the first page load. We can't do that. Full screen can only be triggered by user-generated events, such as click or touch. That's what this error message is telling us. We can't just make JavaScript to automatically trigger full screen. It needs to be triggered by a user-generated event. So instead of running it on the first page load, I create an event listener for a click event on full screen button element we created earlier. When user clicks button, then run toggle full screen. To exit full screen on a computer, you can also just press escape key. On mobile, you can exit full screen by swiping to reveal main controls and press back or home key depending on which phone you are using. Sometimes we get unexpected collisions and game over when player and enemy images are not actually touching, like this. It's because we are checking for collision detection on circular hitboxes around player and enemy, and these circles don't exactly match the sprite sheet image. Collisions between complex shape take a lot of performance, and especially for mobile games, performance is something we need to be more careful about. Phones don't have as much computing power as our desktop computers do. It's usually not a problem when hitbox doesn't exactly match sprite sheet shape, but it should be positioned in a way that it's predictable when collision can and cannot happen. I drew a simple circle around player, and now we can see its collision area. Let's copy this code to display collision area of enemies as well. You can see, when these two white circles touch, we get collision, and since the circles are larger than player and enemy image, sometimes we get collision when player and enemy images are clearly not touching, especially this one when we are about to land from what seems to be a successful jump. How do we fix this? Since player and enemy images are not scalable in this game, they are drawn at fixed width and height, we can shrink and scale hitboxes by a value relative to image size, and we can also move the hitbox left and right by specific pixel amounts to try and match images more closely and make collisions more predictable. We don't want surprise game over like this. I'm using a bit unconventional technique here because sprites are in a sense rectangular. They have starting X and Y position and width and height. But I chose collision detection between circles to remove rectangular edges from sticking out outside player and enemy shapes. What I'm about to do will work with rectangular collisions as well, if you prefer that. We are calculating collision detection between player and all active enemies here. I explained it in the previous episode. We are basically checking distance between center point of player circle and center point of enemy circle, first horizontally and then vertically. We are drawing imaginary right triangle and using Pythagoras theorem to calculate the length of hypotenuse, which is basically the distance between center point of player circle and center point of enemy circle. Then we are comparing radius of player circle plus radius of enemy circle to that distance. If distance is more than sum of these two radii, circles are far apart. If it's the same, circles are touching, and if the distance is less than sum of radii, circles are overlapping. Here I'm just drawing white collision area circle. It's just a visual, it doesn't actually detect collision. Collision is being detected here. We are inside player class, and this is the horizontal center point position of player circle. This is being used for collision detection here. This is vertical coordinate of that center point, which is being used in collision detection formula here. And this is the radius of collision area circle we are drawing, And that same value is being used in collision detection formula here. I can simply offset and resize that collision circle visual in this area and then replicate those changes inside the actual collision detection calculation area here. Let me show you what I mean. What if I want player circle to be smaller? Maybe I don't mind that ears and tail overlap. Let's say they are soft and they don't count when it comes to collision. Also, maybe I want to make my game a bit easier and forgiving. This will allow a small overlap between player and enemy image. What if I want to move the collision hitbox downwards relative to player image? I change its vertical center point position here, plus 20 pixels seems fine. Now I compare changes I made to the visualization and I make sure I update the actual collision detection formula to match these new values. I didn't make any changes to horizontal center point, so that value stays the same. I added plus 20 pixels to vertical center point, so I update it in collision calculation here. I also made the circle smaller, so I update player radius value in this area. We successfully adjusted player hitbox. Let's also do something about enemies. I can, for example, reduce the radius of enemy circle. I also want to move it to the left to cover head of the worm better. Maybe minus 20 pixels for a horizontal center point. I'm actually happy with this. I want collision to only happen when these two adjusted smaller circles collide. Let's take the changed values we used to adjust enemy hitbox visual and transfer them into collision detection formula, like we did with player. I copy this line just so I can look at it for reference. I put it here just temporarily. Collision detection is inside player class, so this keyword here points to player object. If I want to point towards enemy object, I can't use this keyword in this area. We adjusted horizontal coordinate of enemy circle center point, so I need to adjust it here, minus 20. Vertical center point of enemy stayed the same, so I will not be making any changes here. We did change enemy radius, so I will change enemy radius here. And this is how you resize, scale and reposition hitboxes in your game to make sure they match your art assets more closely. I didn't plan to make this episode, but so many of you asked how to add mobile support to our games, so here we go. We can take it much further, but I think this was a good beginner-friendly introduction. Check out full series in the video description if you want. I'll see you there.